So here's our welcome back prompt in a sense. This is prompt number 8. We're just one more to go and we're done with this particular chapter. First thing I asked you is this thing factorable? Now we learned about factoring last time. I gave you this entire chart with 2-term, 3-term, 4-term, what to do with each case.
No.
And so in this case, before you say no, have you tried to use every single thing that I taught you up there? You know, the chart. So let's revisit that again and see if we can figure this out. All right. First of all, this is how many terms? 3. So we call that a what? That's a trinomial. Fine. Is everything in order?
Yeah.
Indeed, right? All the variables, all the powers are in order. Good to go. Okay. Now, if it's a 3-term, what's the first thing? Like, I don't care if it's 2 or 3 or
GCF.
4. We always ask for the GCF. Very good. Do we have a GCF here?
No.
No, we don't. Fine. So we get past that GCF level, and now we're down to what? What are we asking now? It's a 3-term.
Diamond. X. PST thingy.
Okay, well, look carefully. What were we asking now? No, we certainly asked something else. And this is the reason why I asked to practice over your
Put it in
brain,
that
right?
plus format.
If the
But
factors of
I
20
was
out of 7.
talking. What is it?
The factors of 20 out of 7.
Okay, factor 20 out of 7.
If the factors of 20 add up to 7.
What are we trying to get to here?
Oh, never mind. It doesn't.
Okay, wait. First of all, notice that Santino talked about the plus and the minus plus pattern, right? In a sense, it's good. You kind of question that too. This is a minus. That's kind of out of the question of PST already. Cannot have it. But if you look carefully at our chart, PST will signal to have what kind of terms? What's PST? Yeah, perfect square terms, right? In this case, is 20 a perfect square number? No, it's 3x squared perfect square. No. So right at that point, you say it's definitely not a PST, and you can also look at the sign and say, yeah, the signs don't even comply to what we have. You know, it's either a plus or a plus pattern. So it's definitely not a PST. So if it's not a PST, then what are we looking now?
Xbox.
Yeah, Xbox it. Very good. So not a PST. We should start looking at Xbox. So here's your X. Now what do we put on top?
7x.
What do we put on top? Negative 60. Remember this? The 3 and the negative 20 right there will form your product on the top. Negative 60. And see how much you forget over the break? This is the reason why. We need to make sure we practice. What do we put in bottom? Negative 7. Okay, so I have negative 60 on top, negative 7 on the bottom. What times what here will give you negative 60 and add up to negative 7?
12 times 5.
Ooh, okay, so first you said 12 times 5. Okay, 12 and 5 will certainly give you something, yeah, 60. And 12 and 5, you can certainly manipulate the two numbers to get you a 7.
-5.
But which one here has to be a negative value?
Negative 12.
Negative 12. Santino, why not negative 5?
Hold on, let me think. Okay, let's see. 12 times 5 and 12. Oh, okay. 12 plus 5 would be negative. Okay.
There you go. That's the reason why. So, but usually, like I said, the bottom number is negative, then the bigger value will definitely hold that negative value to make it negative, right? So we know we have negative 12 and 5 right there. We have the combinations. What do we do next? Yeah, write it out as 4 terms, right? And this is the part that where people forget a lot. When you write it out, you are replacing this middle term right there. Well, that middle term is the x term, so when you write it, you better have that x variable to go with your number. So when I write it, it's going to look like this. Negative 12x plus 5x minus 20. Here's the worst part, though. See, people always forget the variable. That's one thing. And then when they copy it over, they also copy down the wrong sign. Anything that's not correct here will cost you. Okay, the problem, you end up factoring it wrong, or you can't factor, and you say it's not factorable. So check your sign carefully as you work or write it again. Okay. So here's the box. What do I put in this box?
3x.
3x what?
Square.
3x squared. Next.
Negative 12x.
Negative 12x. Next.
5x.
5x. Next.
Negative 20.
Negative 20. Now, oops. What do I take out on my top row right here?
3.
3x. Okay, so I can certainly take out 3x. because 3 is the GCF for 3 and 12, and x will be the GCF for x squared and x. What about the bottom? 5, positive 5. Okay, now that I have that, I just go ahead and pair it up with the top. 3x times what is 3x squared? X, and 3x times what is negative 12x? Negative 4. So let's test this, make sure it works. That'll give you 3x squared, that'll give you negative 12x, this will give you 5x, and yes, it will certainly give you negative 20. Perfect. Now what? Write it out. So I have x minus 4, and you got times it by 3x plus 5. So this is what we call factored. Okay, it's already factored. Once again, we want to go to the last question and say, is it really completely factored? Well, check it out. There's nothing here that we can actually do. This looks like dots, but x is not a perfect square term, so we can't do anything to it. So we're pretty much done at this point. Okay? I do have another question here, and we'll come back and ask and answer that later. But the question is, can I get the root? The root and the root, whatever.
Can I get a?
Can I get the root? Okay.
No.
No, of course not. Oh, well, we'll get back to that.
We
Okay.
put 2 roots.
Or I'm just going.
Sheesh,
with it.
can I get
Just
the
relax, relax. Okay. All right. So we'll get back to that, but before we're able to get back to that slide, I want to introduce you to the concept of, or the state of z to p. Okay, z to p. All right. It's actually stand for
ZPT. Oh, they're speaking French real quick.
zero product property. You can say z double p or z to p. I don't. Z double P or G2P, okay, whatever. But I don't care if you want to say it. Just make it short. Zero product property. What does it mean now? When it comes to having a zero product property. First of all, let me just show you something here. What's happening when you take a number and times it by 0?
You get 0.
Okay, so it doesn't matter what number that is. As long as I have it multiplied by 0, you will always get what back?
0.
A 0 back. Huh. Okay. What happens if I have a 0 here times by a variable? Do I care?
No.
What's 0 times a is going to get you?
0.
0. Okay. So I can certainly have it, any other variables multiplied by 0, I'll still get back a 0. Is that true?
Yes.
So what I just established right there, guy, is called the zero product property. Anything times 0 is a
Why is it ZZP?
Z2P. Z2P.
You put ZZ.
Oh.
No, I didn't put Z. That's why I have a Z right here. There's a line going through it to indicate that's a Z.
You should.
Fine, I'll make it look a bit better.
Yeah, put ZPP.
Z.
P.
P.
P. There we go.
All right, ZPP. All right, or Z2P. All right. Okay, there. All right.
See, you should
So-
do your choose like that.
What if I have it like this? Now, what does it mean?
One of them is a 0.
Ah. Could it be both?
Yeah.
Yeah. Or either one could be 0, right? A times B equals 0. So as long as I have one of them be equal to 0, I will always make this true. Because 0 times anything is 0. So when I have A times B case like this, and I know it's going to equal to 0, that means A can certainly be 0, or B could be 0, right? Because as long as I have 1 0 for my variable, I don't care whether that one is 0 or not. 0 times anything is still 0. And what we have, like I said, is a Z2P state, or ZPP, or zero product property. Okay? All right. So now if you understand this part right here, then the rest is going to be very simple.
What is? Oh.
Oh, what happened? What happened?
What is that? Or?
Oh, or, yeah. This or that could be 0. Because if this is 0, then 0 times B is still 0, right? Or if B is 0, 0 times A is still a 0. So either this or that. It doesn't matter. Or both. I don't really care. And so, with that in mind, I want you to look at this first problem right here. What's special about this problem is that I no longer have just 9x squared minus 4. I now have it equal to 0. It's not an expression anymore. We now call this a what? An equation. Why an equation again?
An equal sign.
That's an equal sign, and there's something on the left and there's something on the right. We call that an equation. But, most importantly, we see that this equation has something on the right-hand side, or a special number. What is that? It's a 0. It's a 0. Every time we have one side equals 0, we call that the Z2P state, or the zero product property state. We have that. So what does it tell us? Well, that's actually, we're ready to do something a bit more in this sense. First of all, if we have the 0 to P state, zero product property, we just go and look at this right here and say, wait, 9x squared minus 4, does it remind you of something that we learned before? Dots. 2 terms. 9x squared, is that a perfect square?
Yeah.
Is 4 a perfect square?
Yes.
Is there a minus in between them?
Yeah.
Yes. So it's 2 terms, it's the dots, and we realize the dots, therefore we certainly write it like this, right? What do we put inside?
3x.
3x, okay, because 3x squared going to give you 9x squared. What about the other side? 2. Okay, so now that we have it written in the square term, square form, how do we expand this or factor it? 3x plus 2, 3x minus 2. Okay, and of course, don't forget that the right-hand side of this now is equal to 0. Okay, now here's the last step here. There's just one extra step that we have to do now. Because we have achieved the zero product property state, we realize that this times this equal to 0, right? It means that either this is 0 or this is 0. If this is 0, do I care what this is? Whatever that is, I don't really care. So as long as I have this equal to 0, then 0 times anything is still 0. Or if I look on this side, 3x minus 2, if I make that 0, 0 times anything on the left-hand side, still it's going to be a 0, right? So once I have that state, then I can certainly just kind of break it into 2 cases right here. Say, well, let's see if what number will make this first factor 0. So when I write it, I can say, well, 3x plus 2 equals 0. What number will make it 0? How do I solve this? Subtract the 2. You got yourself 3x equals to negative 2, and what? Divided by 3. So x is going to be negative 2/3. Okay, try it out, watch. If I take negative 2/3, plug it back to x, what's 3 times negative 2/3? Negative 2. Negative 2 plus 2? 0. 0 times anything? Still 0. It works, right? Or the other case is this. 3x minus 2 equal to 0. How do I solve this? Add the 2. You got 3x equals to 2, and of course we do the same thing. We divide both sides by 3, and the answer is a positive 2/3. And watch this. If I take positive 2/3, plug it back into this side right here, well, you might say, wait, what if I plug it into here? Of course, you get back a number, right? But if you plug in this x, you have to plug in the other x too. But you plug into this x right here, what is 3 times 2/3? 2. 2 minus 2? 0 times anything? Still 0. It works. So either this or that, x could be negative 2/3, or x could be positive 2/3. So we have 2 possible solutions here. And what we just found right there, guys, are called the roots. Just another form of it. So when if I ask it to solve for 0 or solve for the roots, they mean the same thing. Okay, but it does involve factoring and setting your cases for to make it 0. Okay, any questions so far?
So roots is always just for 0.
Yes. And when we get to chapter 9, you will see what roots really mean. Those are actually just like the intercepts. As you recall, on the x and y intercepts, it has to cross over the axis. The roots right there will cross over the x-axis. And of course, when you are on the x-axis, it has to be 0. Okay? And we're definitely going to visit that concept, so don't worry. Okay. Are there any questions on this before I move on? Pretty much the same thing, except for the last case. Now you just have to set it's 2 cases and solve. Okay? So check this out. See if you can actually recognize this one. It looks a bit strange, but let me ask you this first question. Is this the Z2P state yet?
No.
No? Why? I don't have a 0, right? So how do I make it 0?
Move the 2 over
Move the 2. Yeah. See? I can move the 2, right? How do I move the 2? How do I move a whole term over?
I don't know.
Yeah. Moving. Remember? I mean, you physically take from one side and move it to the other side. Like take away or add, so that's involved adding or subtracting. So that's what's happening when you move a term. Okay? But if you're going to be moving 2 over, don't you have something that looks like this? Is that correct? I just moved the 2 over, right? Subtract 2 both sides, and that's what you see. But you also realize something. Hey, can I do something extra here? Distribute it, right. If I distribute that, what do I have?
3t squared
3t squared
plus 1t
plus 1t minus 2, right? Equal to 0. And guess what? This now becomes what?
V2P. No.
trinomial.
It's a trinomial. And yes, you just achieved the Z2P state. I have a 0 now, so I'm ready to go. It's a trinomial. I also have my 0 on one side. I'm good to go. 3 terms. What do I look for first?
GCF.
GCF. Is there a GCF?
No.
No. Move on.
Xbox.
Is it PSD?
No.
No, not PSD either. Fine. Then what do we do now if it's not PSD? Xbox it. Very good. So here's the X. What do we put on top?
6.
6.
-6.
Negative 6.
-2.
I was in 1.
What do we put down here?
1.
1. Don't forget, middle term goes down. Okay, 1 times 1 here is negative 6. Add up to
2.
3, 2.
3, 2. So I can certainly write that. And which one here is the negative?
-2.
2.
Negative 2. Okay. So I have that right there. What do I do?
Plug it in. 6. Negative.
Write it out.
Write it out. How many terms do I need to write out?
4.
4. Okay, so it's going to be 3t squared plus 3t minus 2t minus 2 equal to 0. Notice I'm replacing the middle term. This is the very important step. You need to learn how to write it out. If you don't have 4 terms, you cannot put it back in the box. And learn to copy correctly too. This is a positive 3 and this is a negative 2. Notice I keep the signs exactly the same. And of course, because I'm replacing the t middle term, I also attach the variable with that. So now that I have 4 terms, what do I do?
Put it in a box.
Put it in a box. Okay, so here's my box. I got myself 3t squared. Here's a 3t. Here's a negative 2t and a negative 2. Learn to copy down their terms correctly as well. What can I take out?
3, 2.
3t. And the bottom?
-2.
Negative 2. First negative, I always take out. Do not forget about that. Okay, if I see a first negative, I take it out. And here, 3t times t is 3t squared. 3t times 1 is positive 3t. And I check it off to see, make sure it's correct. Looks good, looks good, looks good, and it looks good. And now, I just basically have t plus 1 times 3t minus 2, don't forget, equal to 0. How many cases do I have now to solve for? How many cases? 2. And it's kind of simple. That's 1 case. That's 2 cases, right? I have 2 variables, 2 cases. So how do I set this? What's my first case going to look like?
t plus 1
Yeah, t plus 1 equal to 0, right? What about the other case?
3t minus 2 equals 0.
Okay, all right. What's my first one going to be? Negative 1, that's easy. What's the second one? 2/3. 2 answers. You can certainly plug it in and test it, and it works. Because think about this: you take in your negative 1 and plug it in here. You get 0. 0 times anything is 0. It works. And of course, you take in 2/3 and plug it in here. You get back a 0 as well. And 0 times anything is still 0. Okay. So those are called your roots. So notice what's happening. If it's not in the 0 product property state yet, you need to make sure you convert it back into a 0 product property state, either by moving the terms if you have to. Okay, and typically that's the case. And once you achieve it, make sure that all the terms are in order, figure out whether it's a 2 term, 3 terms, or 4 terms, whatever, and use the chart accordingly. Now, I want you to go and try this out on your own to see how far you can get with this problem. Okay, here we go. Okay. 6x squared minus 4x equals to 10. I just hope you realize something, guys. The fact is, 6x squared minus 4x minus equal to 10, of course I told you to make it into a Z2P state, right? So you're going to subtract the 10 over?
Yeah.
You subtract the 10 over, do you not have 6x squared minus 4x minus 10 equal to 0? Okay, so we have the zero product property state. We look here, now it says 3 terms, but you forgot one thing. GCF. Isn't there a GCF I can take out? 2. If I take out 2, don't I have 3x squared minus 2x minus 5 equal to 0? If I can make it smaller, I should, right? But look here. This is no longer just an expression, it's an equation. What's unique about an equation is that I can certainly get rid of the GCF by doing this. This is 2 times this, right? So to get rid of it, I just divide both sides by 2. If I divide it, the right-hand side is still going to be a 0 because 0 divided by 2 is still a 0. But I now can get rid of my GCF, and I just have to deal with that. I just basically make my equation smaller. Instead of dealing with negative 60 on top and negative 4 on the bottom, now I'm just dealing with negative 15 and negative 2. You see it? I simplify the whole process, and now hopefully you can kind of go back here and say, what times what will give you 15 add up to 2? I know I didn't mention anything about negative. I just want you to come up with 2 numbers. Okay, 5 and 3. And then now I go back and say, okay, how do I make this a negative 2? Negative 5. There. And there you have it. A negative 5 and a positive 3. Exit. Now I box it, right? So as a continuation here, I write it to 4 terms. Minus 5 equal to 0. And here's my box. 3x squared minus 5x plus 3x and minus 5. What can I take out in the top? Just the x. Bottom? Just positive 1. Okay? Because there's no GCF except for a 1, so I just write it out. And of course, on top now I would have 3x and negative 5, right? Check. Everything's good. And I just write it. 3x minus 5, x plus 1 equal to 0. I would have myself 2 cases, and what? What's my first answer going to be? 5/3. For those of you who don't know I got 5/3, I just basically set that equal to 0 and solve for x. Add the 5 divided by 3, right? So I'll get 5/3 this way, and over here this should be a simple one. X is negative 1. That's it. That's how I do it. I hope it's simple enough, right? Okay, I need to move on quickly here. And I want you to try this problem on your own this time. There. Do it quickly. Let's see how fast you can do this. So you've seen how we did the last problem. This one's actually pretty easier. Yes. I know. You can still do it that way. But no numbers. Yeah, you can do it. The reason I showed you to take out the GCF because it makes it smaller for you instead of doing it with negatives. Notice I used the 15. Oops, sorry. What's involved here? Is it in the Z2P state yet? No? So what do? Subtract 12, okay. Is that what it is? Any GCF? No, nothing, fine. And PSD? No, not that either. So what do? Just what? X box it, okay. So here's the X. What do you put on top? Negative 36, negative 5. For those of you who start thinking about 6 times 6, well, you know 6 times 6 won't give you 5 ever, right? So what's the other combination? Huh? 9 and 5. I'm sorry, 9 and 4. Yeah, 9 and 4. And which one's going to be negative? 9. So I got that. See it? Got to practice using different patterns. I mean, different combinations, guys. And so I write it into 4 terms. Here's a negative 9x. Here's a positive 4x minus 12. Notice that I'm replacing the middle term, right? That's why my 2 numbers becomes x terms. Here's my box. Got 3x squared minus 9x plus 4x minus 12. Just going to quickly get this done here. Take out 3x, right? Bottom, 4. Top here become x and negative 3. And that's going to check this off. It looks perfect. And it just simply can be x minus 3, 3x plus 4 equal to 0. If you got this far, you know the rest is going to be simple, right? What's my first answer going to be for this one? 3. And what about this one? Negative 4, third, right? Minus 4 divided by 3. And these are my roots, okay? Remember I told you that we're going to get back to the first problem that we did? So I want you to go quickly look at this and tell me, what are my roots for this problem? Can you tell me? Very good. 4, and this one's going to become negative 5 third, right? And just setting it equal to 0. So even though I don't have equal to 0, but if I factor and I said find the roots, set it equal to 0, and solve for x. In this case, it's 4 and negative 5 thirds as my answers. Are there any questions on this one? Okay. Now, if you like to use this for your project, you can also. Okay.